One of the last topics we'll take a look at this semester are indexes, views, and stored procedures. Of the three, we're just going to describe and define indexes and stored procedures. Views we'll actually take a look at and run some examples, and you will be responsible for the syntax of how to create and use views. But don't worry, of those three, views are the most simple to understand, and their syntax is the most simple as well. So let's start with indexes. What is it? It's a copy of select columns that can be searched on very efficiently. So why would we want to do this? So you know what a key value is. A key value is like a primary key. Employee ID in the employee table would be defined as its primary key. And if we were searching on employee ID, where employee ID equals 1234, that search result would come back very quickly. That's just by nature of the way that databases store data. If you search on a key value, that will be retrieved very quickly. On the other hand, if you are searching on a non-key value, what's a non-key value? Anything that's not a primary key or a member of the primary key. So an employee's address, where employee address equals 123 Main Street. That search is going to be more slow because the interpreter has to actually go through each record in all of the columns and look for matches there, as opposed to the primary key, which by nature is meant to be searched on very quickly. And so with an index, we can specify another column on which we can search as quickly as the primary key. So you might be thinking, well, why don't we just index every single column if there are all these great benefits of indexing? The downside is that it slows down updates, because if you are making a change or adding a new employee to that employee table, you need to make the change not only in the employee table but also to that index. The second downside is that it adds redundant data to the database. If we wanted to search on employee address, we're now having to store that employee address field in the database in more than one location, which we learned that redundancy is bad. There's times, like in indexing, when it might be worth it to do it, so that's one of the downsides to be aware of when you want to index a field. And since you're adding redundant data, it increases database size, because if you're storing the same piece of data in more than one location, that takes up more space. So what would make a good index candidate, meaning a field that would make sense to use as an index? Well, I would say non-key fields that you need to search on regularly. Next, fields that change infrequently. We don't want to have an index of a field that will be frequently changing, like, say, age, which if you're storing that in the database, that would have to increase every year, right? Next, shorter fields make more sense for index candidates than longer fields. So a phone number makes more sense than an address for an employee. And that goes back to those downsides of indexes, because they add redundant data and they increase database size. The shorter the field, the less impact that would have. And so how many times has this happened to you? You call up your bank, and the first question they ask you is, what is your account number? Now, I don't know how many of us have memorized our account number. We'd have to look it up in some documentation or our checking book, things like that. And so we're not going to know the answer to that. And when we tell our bank that, we say, I don't know my account number. They say, okay, well, then what is your phone number? Well, I know my phone number by heart. I don't have to look up anything to get that. And so that's really convenient. And likely your bank is using your phone number as an index for your account or your ID for your customer ID in their database. Why? Because that's a field that they would search on frequently. It's not too long, and it would speed up retrieval of data. If the phone number field was not indexed and you gave them your phone number, they could still look you up. It would just take longer. And so instead of looking you up, say, on that customer ID field, which by nature is a primary key and would get query results very quickly, we have indexed the telephone field, allowing retrieval just as quickly. So that's all I have to say on indexes. We will not be creating them in class this semester. Next, views. So views is what we'll spend the most amount of time on. And a view is a virtual table, meaning it doesn't physically exist and take up space like a regular table. It's just a window into a portion of the database. And so why would we use a view when we have queries? Well, we can specify certain views for two reasons. One, for security purposes. We could just give access to the particular fields that a person would need. And next, we can simplify frequently used queries. If there's a query that we're running multiple times a day, it would be nice to store that in a view so we don't have to run our entire query text. We can just run and look at that view. And when you see the examples, hopefully that will make some more sense. The limitations of views is that we cannot specify parameters. A parameter is something that would go into something like, say, a date range. If I wanted there to be a date range in a view, I'd have to set that date range in the view. I couldn't change that date range with every time I ran the view without having to create a new view for each one. Views can only contain one select query. You're not going to get any of the create, update, and delete queries in a view. It's just for retrieval and reading of data. And we can't perform any modifications. So let's look at one of those examples of maintaining confidentiality and security here. So say our employee table in the database contains all sorts of data, some of which is benign, like, employee ID, last name, region, reports to, and hire date. It's okay if everybody else in the company knows that, but that employee table might also contain salary data, or maybe personal information about their choice for their health care plan, things, and social security number, things that the employee does not want everybody else in the company to know. So this company might create a view that would just be those fields that are okay for all of us, other employees, to see. And the syntax, let's take a look at the syntax of this. The first line of the syntax is what's new, but let's look below that, starting with the word select all the way down to the semicolon. That shouldn't surprise anybody. That's a very simple select from statement. We don't even have a where clause. We could if we wanted, but a view is basically just taking a query and turning it into a view. So select all those fields from employees. I don't need to go over that because you understand what that means. Let's take a look at the first line because that's the new part of the syntax. It starts with the SQL keyword create. That's written in all caps because it's an SQL keyword. And I have two spaces after it to keep with our class code formatting conventions. And you've seen that create keyword when we're creating tables. Well, create view is going to do what you think, just create a view. Following the word view, we give the view a name. I'm going to call this view basic employee because it just has some of the basics from that employee table. And finally, this first line ends with the keyword as. Starting on the next line, 8 characters in, we have our select query. Select from, and any of those other keywords and clauses can be a part of this. You can have select from, where, group by, having, order by. All of those are fair game in the body of this select statement. And so let's take this query and let's run it. Get the code here. Instead of typing it out, I will paste it in. So here we are in our SQL developer. The tables over here on the left are the tables from the Northwind database that you've used in class and you'll be using for your data mining paper. And in here is a table called employees. I'm going to double click on that and show you the data view so you can see all of the different fields that we're storing for the employee table? Well, I want to create a view that's a subset of the data in the employees table. And so this is the code I'm running. I'm just going to run the statement, not the script. We should see a confirmation down here saying that the view was successfully created. There it is, view basic employee created. And now over here in our Connections Explorer, if I refresh this, might take a few refreshes. I promise there is a view in there. There it is. So here's the basic employee view that we just created over here. And the benefit, now that we have this view, is instead of writing this query every time I want this basic employee data, I could just do this. Remember, I said that a view is a virtual table. And so usually we see a table after the keyword from, but in this example we're seeing the name of this view. And so here it is. I'm just getting the results of that view. And I can add where statements to here, where region equals WA. If I just want the Washington-based employees, so I shouldn't see Buchanan and Siyama and King anymore. If I ran this, there it is. Great. Let's look at another example. And the second reason to use a view was to simplify frequently used queries. So say we are frequently needing a report of who reports to who. Maybe it's because we need to know who needs to sign off on each employee's timesheet, so that's a useful thing. And so this entire select statement here with a from and a join and an on. We even have some concatenation in there, concatenating a first name with a last name. So that's a query that we might not want to have to copy and paste every time we want to run it. It's worth creating a view called employee and supervisor. Let's now create this view in my SQL developer. I will run that. I should see my confirmation. There it is, view employee and supervisor created. If I refresh this, here is my newly created view over here on the left. And just like before, I can query from that view. So there it is. So those are a couple examples of views. You are responsible for learning this syntax, and on the in-class activity you are doing a couple views as well. So to get rid of a view from the database, it's very similar to the drop table statement. We're just replacing the word table with the word view. And so I will copy this code, paste it in, and we can drop these one at a time. We should see a confirmation. The basic employee view was dropped, and we should no longer see it here. And I can drop this second view and refresh, and now my views are empty. The last concept we'll talk about today are stored procedures. Stored procedures are a set of SQL statements with an assigned name. They're stored in the database in compiled form. Now, what does that mean? Well, to compile code means to turn code that we humans can understand into instructions that the computer can understand. We know that computers work in binary, but we don't write our code in binary. We don't go into a code editor and write 0110 00111. We don't write like that. And so if the code is stored in the compiled form, it's going to run more quickly because that step of compiling has already been done once. And these stored procedures can be shared by a number of programs. Say that you all can register for classes using Louis. right, and peoplesoft.nau.edu, you can register for a course there. Well, also, if you went and saw your advisor, they might be able to register and enroll you in a course using a piece of software, a application that sits on their computer, not through the web browser like you use. Well, both of those tools need the possibility to add a student to a class. And that same stored procedure that would add a student to a class could be used in both that web application and that Windows desktop application. So why would we want to use stored procedures? They are easy to maintain because they're stored in one location. Back to that example, if I had that code in two places, I'd have to update my web application and I'd have to update the Windows application if I wanted to change the code or SQL statements for adding a student to a class. They're faster than queries, I mentioned that before, and they're more secure. You're going to hear more about this next week, the benefits of stored procedures with security, because in instances when you need to access the database, if you have to go through a stored procedure, it ensures that you can only influence the data in the way that the stored procedure allows you to. And so it is good for data loss prevention and hacking prevention as well. The difference between views and stored procedures. Views, as mentioned before, can only do read statements, and only one of them, one single select statement, turning that into a view, a virtual table into the database. So they're much more limited, but if that's all you want, a view makes the most sense. Stored procedures are much more powerful. They can include all of the CRUD statements, create, read, update, and delete. All of those type of statements can be in a stored procedure, unlike just the read statements from views. You can include multiple statements. We could add a student to a class and then also maybe update some table showing the remaining capacity in a class, do two different things, two different statements in one stored procedures. Stored procedures can accept parameters. So that previous example where I said, what if you wanted to restrict the data on date? You wanted a start date and an end date. Well, those parameters could be input differently every time you run the stored procedure and get different results, unlike a view, which if you wanted a separate date range, 5 separate date ranges, you'd need 5 separate views to do that. And stored procedures can include programming logic. These are the things that really make our programs powerful. If you're in ISM 220, you've worked with if statements, loops, and methods. Well, SQL can do all of those things as well, and those are going to happen in stored procedures. So if statements allow your code to branch off if a statement is true or not. Loops are a block of code that's run a certain number of times or while a condition is met. Methods and functions are a series of steps that perform a task or function. And so all of those benefits of programming are available in stored procedures.